SMARC, Smart Mobility Architecture, is a specification published by the Standardization Group for Embedded Technologies EV, SGET, for Computer-on-Modules, COMs. SMARC Computer-on-Modules are specifically designed for the development of extremely compact low-power systems. Generally, SMARC modules are based on ARM processors. They can, however, also be fitted with other low-power SoC architectures, like, for example, ones based on x86 SoCs. Typically, SMARC modules' power requirement is in the range of a few watts, which opens up avenues to markets which to date could not be addressed due to processor designs with much higher power consumption. Computer-on-Modules integrate the core function of a bootable computer, like SoC, as well as additional circuitry, including DRAM, boot flash, voltage distribution, Ethernet, and display transmitter. The modules are deployed together with an application-specific carrier board, whose size and form can be defined to meet customer-specific requirements. The carrier board executes the required interfaces and can integrate, if required, any further functionalities, such as audio codecs, touch controller, wireless communication interfaces, etc. The SMARC specification outlines both the dimensions of the module and the positioning of the anchor points, as well as the connector to the carrier board and, most importantly, the executed interfaces with the pinout. The pinout is optimized for ARM and low-power SoC interfaces and is distinguished from classical PC interfaces by its target-oriented focus on low-power and mobile applications. SMARC is based on the ULP-COM form factor, which was introduced by the companies Contron and Adlink in 2011. During the specification process by the SGET, the standard was renamed to SMARC. SMARC defines two module sizes: 82mm x 50mm for extremely compact low-power designs, 82mm x 80mm for SoCs with higher performance and with increased space and cooling requirement. SMARC Computer-on-Modules have 314 card edge contacts on the printed circuit board, PCB, of the module, which is plugged via a low-profile connector on the carrier board. In most cases, the connector has a construction height of 4.3mm. It is also used for mobile PCI Express Module 3.0 graphic cards, which naturally have completely different pin assignments. Signal transmission is carried out via a total of 314 pins. 33 of these are reserved signal lines for power supply and grounding, so that with SMARC a total of 281 signal lines are effectively available. ARM and SoC typical energy-saving interfaces, like, for instance, parallel LCD for display connection, mobile industry processor interfaces for cameras, serial peripheral interface, SPI, for general peripheral connection, I superscript 2S for audio, and I2C are included. Besides these, classical computer interfaces such as USB, SATA, and PCI Express are also defined. In the current version of the SMARC specification, not all of the 314 signal lines are assigned to fixed I/OS. The alternate function block, AFB, has free pins available for different requirements. This is to ensure that the SMARC specification can flexibly accommodate up-and-coming technical developments which today are not foreseeable, while remaining fully compatibility to previous designs. On the one hand, extended versions of the SMARC specification can assign new standard functions to these 20 AFB signal lines. On the other hand, the SMARC specification 1.0 currently lists the most media-oriented system transport, bus, dual gigabit Ethernet, super speed USB, or industrial network protocols, which from a current point of view could be imagined as or might be assigned as interfaces of the AFB.